All right, y'all, so today we're going to be starting circles. And in this picture that you see, these are a bunch of the different lines that we're going to be talking about. So I'm not going to spend a lot of time talking about them now because we're going to be hitting on each one as we go throughout the unit. But there's some words in here that y'all have seen before, diameter, radius, segment. Y'all have seen the word tangent, but this is going to mean a little bit different. So we'll talk about all these words as we go throughout. Okay, so let's first start with what a radius is. Okay, I think y'all know what a radius is. But it is a segment with endpoints at the center and on the circle. So if I look at this picture, CE is a radius. What else? CF is a radius, but also CD is a radius. And you can name those in either order with those letters. It doesn't matter. Something that's not on here, but that is a question on the homework, that you name a circle by its center. So you see that those are the radii of circle C. So whatever the center is, that's what you name a circle by. Okay, and then when we look at that next word of chord, so a chord is a segment with endpoints on the circle. So if you look at AB, that is a chord, but also DE is a chord because two endpoints are on the circle. More specifically, though, if we look at DE, that is also considered our diameter. Okay, it's a chord that passes through the center, and then it has radii that make up that diameter. You name a diameter from end to end, so we would go DE or ED because it's just a segment. Okay, and the next word that we're going to talk about is this word of secant. Okay, a secant is a line that intersects a circle twice. And so a chord is just a segment, but a secant is an actual line that crosses all the way through. So you see line J there is a secant, and line K is also a secant because it crosses twice. And we'll see some rules about secants like a little bit later in the unit. And then this other word of tangent, this is a line that just intersects your circle one time. So you see this line AB over here, it's just intersecting one time. And that point where it is intersecting your circle, that is called the point of tangency. Okay, which makes sense. That's a point where it's tangent. Okay, so just a lot of really vocab so far. Okay, with circles, kind of like triangles, there's a lot of rules in circles. And so I'll try towards the end, we're going to do like a little summary over circles just to kind of get it all in one place because there are a lot of rules. So the first one says two circles are congruent if and only if they have congruent radii. So if you look at these two circles over here, if I tell you that those two radii are equal, then that must mean the circles are also equal. Okay, makes sense. Okay, in the middle it says that all circles are similar. That means they're proportional. So that's something to keep in mind. I don't think we ask you a test question about that, but there most definitely could be a bonus that has to do with that. So all circles are similar, so they're proportional. Okay, and then y'all have heard this term before, probably concentric circles. These are you may not have heard this definition, but these are coplanar circles that have the same center. So if you look over here, it's basically like a bullseye that you see the smaller circle with A as the center, but then you see that bigger circle, but A is still the center. So they'll have different radii, those two circles, but they can still have the same center. Okay, so I already said this because I forgot that it said it here, but circles are named by their center. So that last circle we just saw would be circle A. All radii in the same circle must be congruent. So that's pretty obvious, right? If you have a circle, okay, all the radii in that circle are all going to be the same length. That's what that's saying. And then if there isn't a circle name, a point located towards the center of the circle, you can assume that that is the center. And you'll be able to tell like when it is and when it isn't. So don't worry too much about that. All right, let's talk a little bit more about this radius and diameter relationship. So we know that a radius is half of a diameter, or that a diameter is 2 of your radii. Okay, and that's going to lead us into talking about circumference. So I just want to make sure, I want to start out by making sure that we understand what circumference is. Circumference is just another word for perimeter. Okay, this is the perimeter of our circle. We just don't say, hey, get the perimeter of the circle. We say, get the circumference of the circle. So this is like if you had a rope tied around this circle and you were to unravel that rope and put it down on a ruler, you are getting the length of the circle. That is what circumference is. Okay, there's two formulas for this. It just kind of depends on what information you're given, which one would be easier to use. So you've got circumference equals pi times diameter, or you can say 2 pi r. So 2 pi r is probably what you've heard before, but if you're given the diameter, it's definitely easier to use that. So this first question says, find the circumference of each circle described. Write the answer in terms of pi. Okay, what does that mean? That means there's still going to be a pi in your answer. That also, if I ever ask for the exact answer, that also means in terms of pi. Okay, that means you can type everything in the calculator that you want. You just cannot type pi in. Because as soon as you type pi in, your number is going to get really nasty. All right, so number one, I'm given the radius, so I'm probably using 2 pi r here. So I'm going to have 2 pi 2.5. All right, and I'm just going to go ahead and simplify that to be 5 pi. So that would be the answer in terms of pi. And if I wanted it as an approximated decimal, I'm just typing that in the calculator. But y'all can all type that in the calculator. I don't need to show you how to do that. All right, the second one, the diameter is 16. Okay, so I'm just going to use pi d here, which means I would have 16 pi. So again, that would be the exact answer, and then you could type it in to get the decimal. All right, number 3 says find the diameter and radius of a circle if the circumference of the circle is 106.4. So here it's giving us the circumference. It would actually be easier for you to use pi d here, but I need to show y'all something that I don't want you to mess up in the calculator. So I'm going to use 2 pi r, even though it's more work. Okay, so it's giving us the circumference is 106.4 equals 2 pi r. And that r is what we're solving for. So that's 2 times pi times r. So when I want to get the 2 and the pi off the r, I'm going to divide. And I might as well divide by both things at once. But here's the deal. If this is asking you to round at the end, you need to be putting that 2 pi in parentheses. So if you are dividing this, if you're going to do it all at the same time, then you're going to have to put the parentheses. Or if you know how to get that fraction up in your calculator so you can hit alpha y equals in your calculator and then press enter, you can get the fraction up, then you don't have to do that because that's already setting that 2 pi apart. But if you type it all in at once, then you have to set it apart. Okay, when you do that, you get about 16.394 for your radius. And then I just keep that number in my calculator and double it, and you get 33.868. Also, if I'm going too fast, just remember you can pause, you can go back, whatever. All right, let's look at this next question. The diameter of circle S is 30 inches. The diameter of circle R is 20 inches, and DS is 9 inches. Solve for CD. All right, so let's see what's going on here. It says the diameter of circle S is 30 inches. Okay, so the diameter is 30, which means this purple piece would be 15 because it was giving me the whole diameter. And then it says the diameter of circle R is 20 inches. Okay, so that would be half of that would be 10. Okay, and then it tells me that DS is 9. And it wants me to find CD. Okay, so I really didn't even need the diameter of circle R. I could have gotten this answer without that. But if you see, CD is just going to be my purple radius minus my green. And that's just going to be, 15 minus 9, which is going to be 6. That's going to leave us with CD. All right, let's look at number 5. A square with a side length of 9 is inscribed. So anytime you see the word inscribed, We haven't seen that word yet, but we're going to see it quite a bit this unit. Anytime you see that word, that means the vertices are on the circle. So if you look, you see this square is inscribed in circle J. That means all of its vertices are on the circle. Okay, and it wants us to get the exact. That means we're going to have, in terms of pi here, circumference of circle J. Okay, so let's see what we're given. We have this square. So if that side's 9, this other side's 9. So if you look at this triangle that we have in here, we have a 45, 45, 90 triangle. So that's our x, x, x root 2. So we have 9, 9, 9 root 2. So our diameter here is 9 root 2. So I might as well just use pi d in this case. So it'd be 9 root 2 pi. All right, let's talk about these always, sometimes, and never questions. So it says a chord is blank a diameter. Remember, a chord is when we have two endpoints on the circle, so that could sometimes be a diameter. Number 7, a secant. Remember, that's a line that goes through your circle 2 times. So a secant intersects a circle blank 1 time exactly. Never, because a secant goes through 2 times. A tangent blank contains a chord. So remember, a tangent line intersects your circle 1 time. Okay, so to be a chord, just to remind y'all what a chord is, that is a chord. So there's no way a tangent could ever create that. So tangent never contains a chord. A diameter is blank a chord. A diameter is always a chord. Always has 2 endpoints on the circle. Number 10, a secant blank contains a chord. A secant always contains a chord because that's what a secant is. It's a chord that just keeps going. So I just drew that in blue on that orange circle. And then the distance from the center of a circle. So I'm going to draw this one. Okay, so we have the center of the circle. So the distance from there to an interior point, okay, so that is just a point somewhere on the inside of the circle, is blank equal to the circle's radius. Okay, so a radius goes all the way to the end. So if that's in the interior, then the distance from the center of a circle to an interior point would never be equal to the circle's radius. All right, so that kind of covers, that's 10.1. Now we're going to start getting into 10.2. This is more geared towards arcs and angles. Okay, so this first concept is that the angles inside of a circle all add up to be 360. So the measure of angle 1 plus 2 plus 3 is all going to be equal to 360. But also, what it doesn't say here, but what it also means is that these 3 arcs that we see are also going to add up to be 360. So the angles add up to be 360 and the arcs add up to be 360. These 3 angles that you see, all of them have a vertex on the circle. Those are called central angles. And what we're going to see is that central angles are equal to the arc that they open up to. So central angles are equal to the arc that they open up to. Okay, and these angles are going to separate these into different arcs. And we're going to go into a little bit more of naming these arcs here in a little bit. But if you look at this picture with the P and the R on it, we have this smaller arc, and then we have this bigger arc. Okay, that smaller arc, again, I think it says this later, but is called a minor arc, and that bigger arc is called a major arc. All right, let's look at number 1. So we're trying to find x. So I'm just going to subtract those numbers from 360, and I'm going to get an angle of 50 degrees. So that angle is 50 degrees. Notice those were all coming from the center. So I know that the angle is equal to the arc. And it is not asking for the arc right now. It's just asking to find the missing angle. But Just keep reminding you that it is central, so it equals the arc. Okay, if I look at number 2, I see that that angle is 90 degrees. So if I subtract those from 360, that leaves the missing one to be 145. All right, so here's, it was on the next slide. I don't know why I said it already. This is talking about minor arcs, major arcs, and semicircles. So a minor arc, so if you look at this picture, arc AB would be a minor arc because it is less than 180 degrees. So you can kind of visualize where a diameter would be. A diameter is going to cut it into 180 and 180 on each side. And so a minor arc is less than that. You're going to name a minor arc with 2 letters. Okay, so you can see this one is called arc AB, when you could call it BA as well. Okay, and then we have our major arc. So our major arc in this next picture, okay, that would be more than 180 degrees. Okay, and you name an arc with 3 letters. Okay, and it needs to be in the order you read it. So in this picture, I could either say that's arc ADB, or I could say BDA. Okay, you never use 4 letters. So even if I added a point on here, let's say I put an E on there, I could say AEB or BEA. Okay, but I have to start with A and go to B, or start with B and go all the way to A. And then otherwise, I can use either one of those other points. All right, and then we have our semicircle. This is going to equal 180 degrees. And you can see that that diameter is splitting that into a semicircle. Sometimes you might see that named with 3 letters. Sometimes you might see just 2. All right, so let's look at this next set of questions. It says PM is a diameter. I would advise y'all to get in the habit of highlighting or at least bolding with your pen, like where those diameters are, because that's going to help you see some things that you maybe don't jump out necessarily. Okay, so it wants us to identify the arcs as major, minor, or semicircles and then find its measure. I find with these, it's easier to go in and fill in those pieces of pie before you actually go answer the question. So that's what I'm going to do. So I go over here and I see that that's 90 degrees. Okay, that means this other one is also 90 degrees because those make a straight line. That's a linear pair. Okay, and then I look on the other side, I have the 115. So that's going to leave this other piece of pie to be 65. All right, so now let's see what it's asking us. So MQ, arc MQ, okay, if the angle is 65 degrees, then the arc is also 65 degrees, and that would be a minor arc. All right, the next one is MNP. Okay, so you can see MNP, that looks like that's 180 degrees. So that's a semicircle. And then this third one is MNQ. So M, N, all the way around to Q. So there's 2 ways you can get this answer. You can add those 3 pieces of pie that we passed through, or you could do 360 minus that 65 that we're not using. Either way. So this would be 295 degrees, and this would be a major arc. But again, the angle equals the arc because it is a central angle. All right, let's look at some of these questions. There may be some that I skip just to save some time. All right, number 6 says, find all the missing angles and arc measures and name a pair of congruent minor arcs. Okay, so I'm going to go over here and I'm going to fill these things in. Okay, you will still have vertical angles. So if you see that you have these 2 straight lines here, that's creating those vertical angles. So this piece is also going to be 50. Okay, I'm going to erase those lines now. And then it looks like we do have a couple of diameters. Okay, we've got one there. So if that's 50, that leaves this open space to be 130 because this would add to be 180. All right, so it says name a pair of congruent minor arcs. Okay, so we can see that EA would be equal to CD. So EA would be congruent to BC. And then B says name a pair of congruent semicircles. Okay, well, I highlighted my diameter, so it's easy to find the semicircles. So I could say arc EDB, that's a semicircle, and EAB, so the other way, would also be a semicircle. Then it says to name a pair of congruent major arcs. Okay, so this one is a little bit different. You've got to be able to find some numbers that kind of all add together to be equal. I actually don't have this answer in front of me, so I am not positive. Okay, but I see that, let's see, this is 180 plus 50. Okay, so that arc that I just highlighted would be 230 degrees. And then, let's see, I've got 130. Oh, here it is. Okay, so from C to B to E, that would be 50 plus 1, so that's 180 plus 50, and that would also be 230. Okay, so I'll just pick another random letter, CB is congruent to EAC. If you need to pause that to actually look at those, you might want to do that. All right, I'm going to skip the next 3. And let's see if we need to do this. I don't think we do. This is just adding arcs together, which is what I just did on that last question. So I don't think we need to do that either. All right, let's look at this question. So we have these concentric circles here. It says, given a central angle of 62 degrees, what is the measure of arc AB and of arc CD? All right, so here I'm looking for the measure. This is going to be in degrees. All right, so if I'm going to look at arc AB right now, okay, that's a central angle that's opening up to that arc. So that means the angle is going to equal the arc. So the arc is also 62 degrees. Okay, and then I look at arc CD. Okay, well, I still have that angle of 62. That's still a central angle, and it's opening up to CD. So that would also be 62 degrees. Okay, so here's the deal. We've got 2 different types of measurements. We've got measure and we've got length. Measure is going to be in degrees. Length is going to be in, like, if you were to put it down on a ruler. So maybe it's in inches or centimeters or something like that. Like if you were to cut that piece of a circle off and put it down on a ruler, you're trying to say, okay, it is this long. Okay, so here's your question then. Is arc AB or arc CD, which one would be longer? If you were to cut that piece of arc off and put it down on a ruler, which one would be longer? Okay, well, obviously CD would be longer. That's a bigger circle, so if we were to cut that piece off, it's going to be longer. Okay, so we have measure, which they were the same measure in degrees, okay, but the length is going to be different. All right, so that's what we're going to lead into kind of talking about now. So we're talking about arc length in degrees. There's a couple different things written here, but the formula that we use is the second one that says equation. And let me talk about where it comes from, and then it'll be easy for you to understand. Okay, if I'm talking about the length around a circle, we're talking about circumference. Okay, so if you see that 2 pi r right there, that is your circumference formula. Okay, and so what you're doing is you're saying, I'm going to get the circumference, but I only want this piece of it. Okay, so that x over 360, okay, so if you look at that circle over to the right, let's say that that angle was 30 degrees. that 30 is what I'm plugging in for x. And I'm saying, okay, I only want this ratio or this amount of the circumference whenever you're getting arc length. All right, so let's do these questions. It says determine the length. Notice it's saying length. If this said measure of AB, the measure is 45. But the length is like if we were to cut it off, put it down on a ruler and measure it, how long would it be? Okay, and then it says express your answer in terms of pi and rounded. I'm probably just going to do the in terms of pi answer. All right, so here I'm going to have my length equals 45 over 360 times 2 pi r, which is 3. Okay, if we're getting our answer in terms of pi, that means you want to type everything in except the pi. Okay, so again, if you'll type your fraction, if you do the alpha y equals thing, it makes this a lot easier because it gives you the simplified fraction when you're done. But if you type all of that in without the pi, you're going to get 3/4, and then we have the pi. So the length is 3/4 pi. Okay, if that was a decimal, it would be 2.356. So it's like, okay, it's 2.356 centimeters long. That's what that's saying. Okay, sometimes the decimal does make more sense to us. When we see that pi on there and we don't see the actual number, it's a little confusing. All right, number 14. So again, we're getting the length of AB. Okay, well, the angle that's opening up to that is 80. So I'm going to have 80 over 360 times 2 pi, and then our radius here would be 7. So I would type everything in the calculator except the pi, and I'm going to get 28 over 9 pi. Or, if the decimal here makes more sense, it's 9.774. So it would be like 9.774 meters long. Be a very big circle. All right, I'm not going to do the next one because it's exactly like that. All right, and then the last part of today is talking about radians. So let me just give you a brief kind of intro into radians. And I'm actually not going to read any of that stuff up there. I just want to first tell you that radians is just a different form of measurement. Okay, so think about when you go outside and you were to measure the temperature. Like we may have Fahrenheit and we may have degrees. Fahrenheit or Celsius. If I measure how tall I am, I could measure myself in inches or I can measure in centimeters. Okay, there's different forms of measurement for the same thing. And so that's kind of a way to think about degrees and radians. So what I've done is I've actually found this picture. I thought it kind of explained it well. But now I don't know where that picture is. I think maybe it's still in the last slide. So let me pull that up. Nope, it's not there. Okay, well, I don't remember where it is. But if you want to Google, like what a radian is, and then I can talk about it more in class next time. But radian is basically, if you were to take that arc and like make it straight instead of curved, that is 1 radian. Okay, so it is not really important at all that you understand what a radian is, but we're going to be converting from one to the other. So think about if you had to convert from Celsius to Fahrenheit and back and forth. That's what we're going to need to be doing. Okay, so I'm going to read this definition of a radian, but I need you to understand that it is not that important that you understand what a radian is. You will do this a lot more in pre-cal. So this says, what is a radian? It is an angle subtended from the center of a circle which intercepts an arc equal in length to the radius of the circle. Okay, so you can see the radius, okay, is going to be equal to that piece, and that is 1 radian. Okay, again, don't worry too much about it. Okay, but here is our conversion formula. So we're going to have degrees. So I'm just going to say that's D times pi over 180, and that is going to get us our radians. This is not, you're not going to get a chart for this. I will teach you a trick. You are either going to be multiplying by 180 or you are going to be dividing by 180. You need to decide if you're going from degrees to radians or radians to degrees, which one makes more sense. Okay, and we're just going to keep this as simple as we possibly can. Okay, so the first section says to convert the following angles from degree to radians. I'm going to do this first one by writing it all out, but then we're going to just do a trick. Okay, so the first one says 360 degrees. So remember, we have d times pi over 180. That's going to equal our radians. Okay, that says that up there. So I have 360 times pi over 180 is equal to my radians. Okay, so that would be me doing 360 divided by 180, and that gets me 2 pi. Okay, so you see there, we divided by 180. So you could sit here and you could plug that into the formula, or just think about, like, does it make sense to multiply 135 times 180? No, that does not make sense. You would get a humongous number. Okay, so these are the ones where I would divide by 180, and then you're going to put a pi on it. Okay, so this next one would get me 3/4 pi. Number 18, 60 divided by 180. Okay, that's going to get me 1/3 pi. You just got to put the pi on it. You're either multiplying by 180 or you're dividing by 180. So in this section, we're dividing. So divide by 180, put the pi on, and you get 7/6 pi. That's the measure in radians. Okay, which means when we're going the other direction, we're going to multiply. But again, I want to show you on the first one why this is. So we have degrees times pi over 180, and that is going to equal our radians. But our radians here, they gave it to us as 5/6 pi. Okay, so let's think about what we would have to do to solve this. Okay, well, I have a pi on both sides. Those are going to cancel out. So I still have that divided by 180 on the bottom. So I need to multiply both sides by 180 to solve for degrees. So that leaves me with degrees equals, whoops, I just wrote the wrong number, 150 degrees. So 5/6 times 180 is 150 degrees. So you'll see in this section, we're just multiplying everything by 180. Okay, if you divided these by 180, you're going to be getting really, really itty-bitty numbers. Okay, that would not make sense. All right, so on 21, we would get 315 degrees. On number 22, we would get 270 degrees. And on 23, we would get 240 degrees. So you're welcome to use the formula and solve for it algebraically, but to me it makes sense as long as you know whether you're multiplying or dividing. I don't think you need to know any more than that. All right, the last thing that we're doing, I'm sorry, I know this has been a lot. Okay, we talked about what a radian is, kind of, and how to convert, but this is actually us getting arc length. But instead of getting it in degrees, we're going to get it in radians, okay? So I'm going to show you both. I'm going to show you what we have already done. So this first one, notice that that angle is in degrees. So I am going to use that same arc length formula that I used. So that's going to be 30 over 360 times 2 pi, and then times 2 my radius. Okay, and I'm going to simplify this. So if I simplify this, this is going to be 1/3 pi. Okay, so again, that's our degree formula. Okay, arc length in degree. If I were to cut that piece of circle off, put it down on a ruler, that's how long it is. Okay, but if you look at this next one, this next angle, you'll see it has that pi on it. That tells me that is in radians. Okay, it also doesn't have a degree symbol. That tells me it's in radians. Okay, so the formula for this is actually easier. If you were to look at a formula chart, this is what it says. It says it has this symbol. It's called theta. That just represents a variable, basically. And it's saying take that angle that's in radians, and then you're going to multiply it by the radius. So I'm going to have length equals my angle that's in radians, so 3 pi over 7 times my radius. This one's actually easier, I think. I don't even have to pick up a calculator for this because I can do 3/7 times 5. That's 15 over 7 pi. So we see the difference. So you do need to know both of these formulas. I think the one in degrees is easy to remember because you're just taking like a ratio of your circumference. But the arc length formula for radians, I don't think it's hard, but it is kind of one extra thing you're going to have to remember. All right, we're just going to do a couple of these. We are not doing them all. Let me just do the first two. So it says to get the length of arc YZ. Okay, and I look at this angle here, and it is in radians. So I'm going to use that radians formula. So I'm going to have 7 pi over 12 times my radius. So that would be 14 pi over 12, which goes down to 7 over 6 pi. See, don't even have to pick up my calculator for that. Okay, number 25, again, getting the length of arc YZ. And that angle, again, is in radians. So I'm going to have length equals 3 pi over 4 times the radius of 9. So that's going to get me 18 pi over 4. I don't know why I just said 18. That's 27. Yikes. All right, so 27 pi over 4. There we go. Okay, there's nothing any crazier on the next two. Okay, so just make sure that you get your class kick done. Raise your hand on there if you have any questions. And then I will kind of reteach little parts of this. I'll go through the homework next time with y'all.